You're first going to distribute your denominator factor into each individual term of your numerator. Okay, so what that means is, if I were to split this into the two problems, if I take my first problem and I write down each individual each individual term of my numerator as its own separate fraction, and individually divide each of those by whatever's in my denominator. Okay, and so that's the first step. Okay, once you distribute that denominator into each term of your numerator, you're then going to simplify each of the fractions. Okay, and when you simplify these fractions, you're going to use rational powers. You might use negative powers. Okay, but there is a specific form I want you to write your answer in. And so that form will be apparent on these two examples. Okay, but the first thing you would do is simplify your fraction. So here my coefficients don't simplify, but my variables do. This x cancels with one of these, leaving one. This x cancels with that x. Okay, and so when I write my simplified answer, you're always going to write it using your coefficient first. Okay, so the coefficient includes all the numerical parts, numerator and denominator. So I'm going to start here with 3/2. And then put my x to whatever power that happens to be to, power of 1, minus my next fraction. The x's cancel completely, so just minus 7/2. And my next fraction, start with my numerical coefficient, 5/2, and then write x to whatever power it happens to be. Notice here my x is in the denominator with a power of 1. So when I write that as x to some power, I'm going to use what? -1. Okay, and so this is how I would want you to enter that solution. Now, if you're looking at values that have either radicals or rational powers, what you would need to do is to put it into its rational power form. So this would be the square root is equivalent to a power of 1/2. And then do the same steps. Distribute your denominator into each individual term of your numerator. So I would start by writing each term, 2x to the 5th plus 5x squared minus 1. Divide each of those by my denominator. So my denominator is x to the 1/2, x to the 1/2, x to the 1/2. And now if I am working with rational powers, what I want to make sure I do is make sure you treat all your numerical powers in the same fraction form. So since my denominator's in terms of halves, I want to write my powers in the numerator also in terms of halves. So 5 is 10/2, 2 is 4/2. And so when I rewrite them in those forms, I can now simplify. When I divide exponents with the same base, I subtract their powers. So I have numerically a 2, and then 10/2 minus 1/2 gives me x to the 9/2, plus my next fraction, or my next term, 5. X to the power of 4/2 minus 1/2 is 3/2. Minus 1, I can leave that unwritten, x to the power of, and once again, it was in the denominator, so I change it to a negative, and that would be my rewriting as the sum of terms form for that problem. When you rewrite this as the sum of terms, we separate and write our each individual term from the numerator first. Okay, I will write them in standard form from highest degree to lowest degree. In this case, they're already written in that form. I'm then going to distribute my denominator into each of those. And I'm going to simplify the result. So here, my negatives cancel, my negatives cancel, my negatives cancel. These 5 z's go into the z's in the numerator, leaving 2. These 5 z's cancel completely. And when I'm looking here, these 3 cancel with these, leaving 2 in the denominator. And so if I write my simplified form here, I have a 2z to the 2nd for my first term, plus 9, my z's canceled, so just by itself, and then plus 5 times z2 here. The power is 2, but it's in the denominator, so I need a negative, and this would be my simplified form. When I'm dealing with the rational power, the same idea or the same first step holds true. I'm going to write each individual term of my numerator. Oops. As I do this, though, I am going to put it in standard form. So I'm going to start with my highest degree, which is 3y to the 6th, and then minus 8y to the 5th, and then minus y cubed. Okay? It should accept any order. Okay? However, it's just consistent to be always from highest to lowest. My denominator I'm going to distribute into each of those, so y to the 4/3. And notice, because I'm in a rational power form, I want to change all of my powers to rational power in terms of the same fraction, thirds. So 6 is 18/3, 5 is 15/3, and 3 is 9/3. So if I think of them in terms of those rational forms, it's just going to make it easier to combine them. And now when I divide exponents with the same base, I subtract their powers. So I get my simplified form of 3y to the 18/3 minus 4/3, or 14/3, minus 8. 15/3 minus 4/3 is 11/3. And then minus here, you get just the minus 1, base y. 9/3 minus 4/3 is 5/3. And so this would be the simplified form I'm looking for. Questions? No, the order shouldn't matter. It's just usually things will be written in standard form, highest degree to lowest.